Hello, in this module, we take a look at the very important concept of EM wave polarization. So we understand what is the polarization, what are its types, and what is the use of this concept in the theory of electromagnetic wave. So we see that this picture again, we have a typical electromagnetic radiation which is radiating into the space in the direction indicated by X. On the Y plane or Y axis, we have component of electric field. On the Z axis or Z plane, we have component of magnetic field indicated by the red sinusoidal waveform. And we also already defined it. It is a transverse electromagnetic wave. It means the components of electric field and the magnetic field and the direction in which it is propagating all are 90-degree phase shift to each other. That is the orthogonal. They are orthogonal or perpendicular or transverse to each other. That's why we call it. Now, what is polarization? Basically, when this wave transmits into the space, it is radiating into the space. So in this waveform, the component of electric field that defines the polarization. So it means polarization basically is indication of in which direction the E field is oriented. So in this case, you see that orientation of electric field is in the y-axis, positive y-axis and the negative y-axis with respect to the direction of propagation. So this E field component orientation can vary. The orientation of the E field can vary. It could be in the Z direction, it could be in the X direction. So we will say that we will look at the waveform and we'll see in which direction E fields pointing. And that is called as polarization. Now, let us have a look at what are the types of polarization. So in this picture, we have three types of polarization. First is called as linear polarization in the first picture. So you see that indicated by the arrow, the component of electric field is radiating in the direction indicated by arrow, and let's say we can call it as x-axis, y-axis or z-axis. So in any direction it can transmit, and orthogonal to each would be the component of magnetic field, for example right here. Now why we call it as a linear polarization type? Because here if we assume this sinusoidal waveform is a E field, so its orientation in a particular in up and down indicated by this line here. So E field here oscillates in the fixed direction, up and down, along a straight line. That's why we call it as a linear polarization. This means at any point in time, the electric field vector would point in a specific direction. So in this case, it is pointing in a up and down direction. That's why it is called as linear polarization. Second type is circular polarization. So you see the E field vector here indicated by the dark uh, red shape right here. It rotates in the circular fashion. So it is rotating in the circular fashion around the axis of propagation. So this is your axis of propagation, and the E field component is rotating around the circle around the axis of propagation. So it can rotate in a right-handed direction or it can rotate in the left-handed direction. Depending on the direction of rotation, it is called as right-handed circular polarization or left-handed circular polarization. So right-handed means it is rotating in the clockwise, and left-handed means it is rotating in the anti-clockwise. Now, third and final type is called as elliptical polarization. It is similar to the circular polarization, but you see that it is taking an elliptical shape, again shown by the dark shaded red sinusoidal waveform. So this is the axis of propagation, and the component of E field is rotating, tracing out in an elliptical path over the time with respect to time along the axis of propagation. So remember, polarization means always we focus on E field vector of an electromagnetic wave, and based on the wave it is oscillating, the vector oscillating, we define it is linear, circular or elliptical. Now the polarization of electromagnetic wave is determined by the way the waveform will be generated. Okay, so let's say these are the transmitting antennas and they are radiating the EM wave into the space, and that could be linear fashion, that could be circular fashion, that could be elliptical fashion. So the E field vector will oscillate along the axis of propagation in a specific way. So these antennas can produce linearly or circularly or elliptically polarized waves based on the way they have been designed. What is the use of polarization? So first is, we can transmit multiple signals simultaneously. What is the advantage? It can help us to reduce the interference between them. Let's say we have multiple signals to transmit. For example, FM wave radio signals. There are multiple channels, so each waveform can take different polarization, linear, circular, or elliptical, so that the interference between them will be reduced. Circular polarization is used in 3D classes. We go to see the movie, and we have displays various. So the electromagnetic radiations in that case, the EM electric field vector will take the circular polarization, that is to separate the left eye and right eye images. In satellite and radar application, this concept of polarization is used to analyze different surface properties and the material. And finally, we can say another use, polarized sunglasses. They will block the horizontally polarized light to reduce the glare from reflective surface. What is horizontally polarized waveform or vertically polarized waveform? Let's have a look at this picture. So if we say that blue is indicating the electric field vector, it is going up and down, oscillating in up and down in a straight line. So this is a linear polarization, and in the linear polarization, it is vertical linear polarization. Imagine the blue sinusoidal waveform is in the place of red sinusoidal waveform. So imagine the red takes the place of blue and the blue waveform takes the place of red. So in that case, we will say that the electric field component, which is now the red waveform, for example, we will call it as a horizontal linear polarization, because it is going, you see these arrows, red arrows, it is in the Z plane, positive Z and the negative Z. Okay, so we call it as a horizontal polarization. So that was the concept of polarization.